How does the brain recognize objects no matter how we see them and keep our vision stable in a constantly changing world? Welcome back to DeepVisus, where vision meets depth and we explore the profound workings of the mind behind what we see. Today, we're diving into chapters 6 and 7 of Stephen Grossberg's Conscious Mind, Resonant Brain. We're tackling two powerful questions. How does the brain learn to recognize objects regardless of where they are, how big they appear, or from what angle we see them? And how does our visual system keep our perception stable even as the world around us and our eyes are always moving? Let's start with object recognition. Imagine looking for your friend in a busy crowd. You don't just memorize one photo of them. You recognize their face from different angles, distances, and even in varying light. How does your brain achieve this remarkable feat? Grossberg explains that the brain builds invariant object categories, mental models that recognize the essence of an object regardless of changes in view, position, or size. These categories are formed in the brain's inferotemporal cortex through a process involving both your eyes scanning the scene and complex neural circuits coordinating two key streams of information: the what stream, which identifies objects, and the where stream, which locates them in space. But recognition alone isn't enough. The brain also needs to maintain spatial attention on the object surface. This is where the concept of surface shroud resonance comes in. It's a dynamic neural handshake between brain areas that sustain your focus on the object surface as you scan it from different angles. This resonance prevents your perception from collapsing as your gaze shifts, helping to keep the object stable in your awareness. These processes also explain some intriguing clinical phenomena like visual neglect, where damage to parts of the brain's parietal cortex disrupts this attentional resonance, causing people to ignore half of their visual field, literally not seeing part of the world. Now, let's talk about stability in a world that's always changing. Our eyes dart around, our heads move, objects come and go. Yet, somehow we don't experience a chaotic blur. Instead, we perceive a stable, continuous visual world. How? Chapter 7 reveals the brain's answer. It uses boundary reset mechanisms and predictive remapping. As you move your eyes, the brain actively updates and resets visual boundaries to keep them clear and consistent, avoiding perceptual smearing or streaking. Even more fascinating, our visual system has two parallel processing streams, one for static shapes and another for moving forms, allowing us to track motion smoothly while recognizing objects. This balance of updating and stability is critical. Without it, moving objects would appear ghostly or distorted. The brain's predictive systems anticipate eye movements, transforming visual inputs so that our perception stays seamless and reliable. So, to answer our big question, the brain recognizes objects invariantly by learning flexible, stable categories while continuously coordinating attention through surface shroud resonances. At the same time, it keeps our perception stable in a dynamic world by resetting and remapping boundaries as we move and as objects move around us. This complex dance of learning, attention, prediction, and stability allows us to effortlessly navigate a changing visual environment and recognize the things that matter to us, even when those things look different or move. If that opened new doors of understanding for you, then stay tuned. Next time on DeepVisus, we'll explore how the brain processes motion and integrates moving objects into our stable perception, diving even deeper into Grossberg's visionary theories. Until then, keep your eyes and mind open, because DeepVisus is where vision meets depth.